So to start out, we're going to create a new file by clicking File, New File, and then RScript. When you go to open up RStudio, you can see that there's a lot of panes open. So at the bottom right is the Outputs pane. Right now you see the Files tab open, but you can also tab over to the Plots tab when we go to create visualizations. But in the Files tab is where you can locate and open up script files into the environment, and they'll appear here at the top left as different tabs. If you have any questions about something like, let's say a data set or an operator or something like that, you can actually ask RStudio by typing in a question mark followed by whatever you have a question about. So we're going to learn about arithmetics pretty soon. So let's try that. And then you can see that it opened up a tab in the Help tab where it shows you everything you need to know about arithmetics here for R. And then what's neat about RStudio is that you can create headers to section out your code and then navigate to them in the Outlines panel here. And you can adjust the hierarchy of the sections by adding more or less hashtags. So this one's going to be header 1. And then you have to follow the hashtag, the header name. You have to follow it by 4 dashes. And see, you can see that it appears here at the right inside the outline section. To adjust the hierarchy for the subsections, I'm going to put more more hashtags. And see, it's indented. But for comments, it's the same as anywhere else, where it's just a hashtag. And it doesn't appear into the outlines, but it is indeed a comment because it's highlighted in green. One more. Okay. Now to test things out, we'll type in, well, first let's name our header. Okay, let's type in 1 plus 1. It works the same like Python, where if you type in an arithmetic expression here and then you run it, which, oh, by the way, you can run lines one of 2 ways. So first you would have to click into it. Make sure it's not like highlighted like this. Otherwise, RStudio will try to run just whatever highlighted within. But you click into a line and then you hit Control Enter for Windows users, or you can use Command Return for Mac users. Or you can go up here to the Run button and then click Run, and it should give you the same effect. But anyways, when we run this expression, RStudio will spit out the answer into the console pane in the bottom left. It works the same like Python, where if you type in an arithmetic expression here and then you run it, which, oh, by the way, you can run lines one of 2 ways. So first you would have to click into it. Make sure it's not like highlighted like this. Otherwise, RStudio will try to run just whatever highlighted within. But you click into a line and then you hit Control Enter for Windows users, or you can use Command Return for Mac users. Or you can go up here to the Run button and then click Run, and it should give you the same effect. But anyways, when we run this expression, RStudio will spit out the answer into the console pane in the bottom left, and you can also see that there's a 1 besides the output. This is just a subscript that shows where the first element on the line is indexed in an array. So since there's only 1 element inside this array, it automatically has an index of 1. If you have, say, an output that spans across several lines, the subscript will be different and reflect the index of the first element on that array. I'll show you what I mean. So indexing in arrays, that's going to be our header. And then we're going to do 1 through 50. Okay, so if I print out numbers between 1 and 50, it will show in the console that the first element on the first line is at index 1, and then the first element on the second line is indexed at 32. Now indexing starts at 1 in R, unlike languages like Java or Python, which remember start at 0. But if I ever change 1 to 5, then you see that the subscript properly display which index the first element on the line is in the array. So element 1 is the number 5, but it's at index 1. And then if you keep counting, if you get to number 35, you'll count that it's actually index for 31. So on the second line, the first element on it, 36, will actually be index 32. Another thing that's very similar with Python is the print function. It's the same thing with beginning the command print and then encasing whatever you want to print out with quotation marks within the parentheses. So of course we're going to do hello world and then print it out onto the console. And it just says hello world. You can think of an object as a container that stores values inside it. When you assign a name to the object, it will be stored in the environment so that it can be retrieved later. And you can create and name an object by typing its name. So let's name this section first. So type its name, ours will just be X, and then you point an arrow at it with the value being on the other side. So we're going to assign the value 55 to X. So 55 goes into X is what this is saying, because the arrow is pointing at X. If you run this out and then look at the environment, you can see that it is now stored with X being the object, and then it's going to be assigned the value 55. This tab will also display things currently active in RStudio's memory. This can also work in the opposite direction if you like it that way, like, I don't know, if you're weird like that and you want the value before the object. All that needs to happen is that the object needs to be having an arrow pointing at it and then the value on the other side. So if we run this, you'll see that it works. So 22 goes into Y, and then here they stored it into the environments pane with the value 22 to the object Y. You can also assign the same value to multiple objects at once by, again, making sure that the arrow is pointed to that object name. And an example of this would be, let's do ABC. A, B, C. And then we're going to assign 77 to all of them. So if you look on our environments pane, you can see the objects ABC all got a value of 77. You can also store multiple values into one object using the C function, which combines a list into a single object. The default one is a vector that shows just one row of the same data, and there's more than one kind of data structure you can create in R, but I won't go into much detail in this TD since I believe you'll do more work with already provided data. So for the C function, we're gonna do an object called D, and we're gonna use the C function to store values 1 through 5. Okay, so the values 1 through 5 are separated by commas, and they'll be stored into the object D. And over here, that you can see that it automatically identified the data type as a numeric data type, and it saved it in an array of 5 indexes and elements 1, 2, 3, 4, 5. Oh, and I think I forgot how to show you how to call on the object, so you can just simply type the object's name, D, or you can print it out using the print function. Give you the same result in the console. And what's neat about R is that you can also manipulate objects, interact with them with other objects. So if for whatever reason you want to add, subtract, multiply, or divide elements into an object from one another, you can do that by, hold on, I might have to create another multi-value object. So object I think that's how you spell manipulation. And then we'll create an object called E, and we're gonna hold another set of numbers 6 through 10. Okay, so let's say I want to subtract D from E. I can just type E minus D, and then the computer will subtract the corresponding element D and E. So if you go over here, subtract D from E, 1 minus 6, 6 minus 1 is 5, 7 minus 2 is 5, 8 minus 3 is 5, and so on and so on. So this seems like the correct answer. And I can also manipulate the elements in a single object by using them in expressions like, did we do an x? Yeah, we did an x variable. X times 2 or E times 3. And it'll do so in the console without reflecting it into the saved environment. So as you can see, E is still 6, 7, 8, 9, 10, but since I multiplied it by 3, now it's 18, 21, 24, 27, 30. Same thing with x. X is 55, but multiplied by 2, it's 110, but it's still 55 inside the environment's pane. Now these operators only work for numeric objects only, so you won't be able to, let's say, f, this is going to be an object, and we're going to use a character data type. This is a character data type. Oh, and make sure that every element in your object is the same data type. Otherwise, I'll categorize it maybe something you intended for a numeric value instead of a character value. So here we go. So this is a character data type, but if you add, let's see, we'll combine it using the C function. If you add a numeric data type with this character data type, as you can see over here, it's saved as a character data type 22, even though we didn't put it through quotation marks to identify as a character type. Since the other data type is, it actually transfers to a character data type instead of a numeric. You also won't be able to multiply the object f or add it to another numeric object like f times 2. It'll give you an error message in the console. You can do x plus f, and then same error message. Hold on. Let me name the section. Nope. Data types. Okay, so if you don't know what type your object is, you can type type of and then the object name. So we're going to see what f is and then what x is. Okay, so it will show you in the console, and as you can see here, it says double, and that's because R doesn't automatically differentiate between integers and decimals unless you specifically ask for that. And now for booleans, you can either do them one of two ways. You can spell out true or false in all caps, so let's do G, and then true in all caps. And then as you can see, it's recorded here as the logical value true. And just make sure that it's all capitalization for each letter, and you spell it out correctly so that it knows that it's not, let's say, like a character data type. Or it'll give you an error message, I believe, too. Let's see. I think I'll give you an error message. Yeah, okay. Oh, the other way is to just do T or F, and it'll give you the same result. So even though we entered only the first character of false, it automatically did the logical value true. I'm sorry, false. I'm blanking out.